Hello, I'm very excited that our objective today is to demonstrate the effects of changing dimensions on perimeter area and volume. Part 1 of this video is going to focus on numerical analysis, and part 2 is going to focus on algebraic manipulation. So let's jump into it. It starts by just giving us some information about some triangle. It says it has a base of 8 and a height of 15. And I gave you a little picture here as an aid. I did not need to make it a right triangle. It all would have been the same no matter what, but I did. So since this is a right triangle and 8 and 15 is part of a triple, we know that the hypotenuse is 17. The perimeter and area, of course, would just be, the perimeter would be all the sides added together, but what I would like you to write is this. P sub 0 means the original perimeter. The next section is going to have us changing this perimeter. So the original perimeter is 8 plus 15 plus 17, which comes out to 40 units. And then we'll do the same thing for area. The original area is 1/2 base times height, so 1/2 times 8 times 15. So this comes out to 60 units squared. So again, P sub 0, A sub 0 means original perimeter, original area. Part B and C ask what happens to this perimeter and area if the dimensions triple. So I gave you a little triangle just to think about it. And if the dimensions triple, well, each of these would be multiplied by 3. So that would give us 24, 45, and 51. So the new perimeter, this time I'm just going to use P, is equal to 24 plus 45 plus 51. And if you add all these together, you get 120. Now, the question isn't what is the new perimeter? That's not anything really interesting. The question is what happened to the perimeter? So what I want you to consider is this. The perimeter divided by the original perimeter. So P divided by P0 is equal to 120 divided by 40, which is 3. Sorry, I drew a line that made this hard to see. Well, what that means is that the perimeter has multiplied by 3, which shouldn't really be a surprise because the dimensions tripled. So our answer to this question, what happens to the perimeter? I'm going to say the perimeter multiplies by 3. I'm sorry I didn't give a lot of space for this, but this is the answer to the question here. Now let's do the same thing with area. What happens to the area when the dimensions triple? So our new area is 1/2 base times height, so that's 1/2 times 24 times 45. And I'm grabbing my calculator for this one. 1/2 times 24 times 45 comes out to 540 square units. But again, my real question is, how is that changed compared to the original? So what I'm going to do is my area divided by my original area. So in this case, that would be 540 divided by 60, which comes out to 9. Now you notice this is not the same thing. The dimensions tripled, the perimeter tripled. The dimensions tripled, the area multiplied by 9. And that's going to be our answer to this question. Area multiplies by 9. I'm going to do one more example here. If the dimensions quintuple, what happens to the perimeter and area? Quintuple, of course, means times 5. So each of these numbers times 5 would give us 40. 15 times 5 is 75. And 17 times 5 is 85. So in this case, our perimeter is those added together. And if you do that, it comes out to 200. I know I'm doing this fast, but it's just adding. What I really want to know, of course, is how is that changed compared to the original? So P divided by P0 is 200 divided by the original perimeter was 40. And when you divide those, you get 5. So, of course, what that means is that the perimeter has been multiplied by 5. Again, not really a surprise because all the dimensions multiplied by 5. Before I do this, I want you to make a guess in your head about what the answer is and see if you're right when we get there. The area of our new triangle, area is equal to 1/2 times the base, which is 40, times the height, which is 75. Again, I grabbed my calculator for this one. So 1/2 times 40 times 75 is 1,500. What I really want to know is how is that compared to the original area? So I'm going to do my area divided by the original, and that is 1,500 divided by 60. And when you do that, it comes out to 25. If you guessed 25, or if you used a pattern, I'm very happy that you got it. You probably noticed 3 squared is 9, 5 squared is 25. This pattern is going to hold up, and even though I'm going to ask you to show work, that doesn't mean that you can't predict the answer before you start. So our answer to this one is that the area has been multiplied by 25. We've got one more example in this video, and that's the volume question. So what happens to the volume of the shape if the dimensions double? So we're going to do this the same way. Our volume here, our original volume, this is a point solid with a circular base, is 1/3 pi r squared. So that's pi times the radius of 4 squared, times the height, which in this case is 9. When you multiply all this out, we get, let's see, this is 16, and then that's going to be times 3. So this is 48 pi. So our volume is 48 pi cubic meters. And now let's consider what happens if the dimensions double. I didn't give you another drawing here, so I'm just going to kind of do this in my head. If the dimensions double, this is now 18 meters, and this is now 16 meters. So our new volume is equal to 1/3 times pi. The radius is now 8 instead of 16. I'm sorry, 8 instead of 4. And the height is now 18 instead of 9. And so our new volume comes out to be 384 pi cubic meters. Finally, we're going to compare these because this is what we really want to do here. My volume divided by my original volume, in this case, is 384 pi divided by 48 pi. You don't need to worry about the pi's, they cancel out, but 384 divided by 48 is 8. So the answer to this question is that the volume multiplies by 8. So if the dimensions all multiply by 2, the volume multiplies by 8. Our objective today was to demonstrate the effects of changing dimensions on perimeter area and volume, and we focused on numerical analysis in this first part of the video.